The story around black holes has really changed in the last few years, amazingly so. In Einstein's time, black holes were just a mathematical oddity, a thing which was possible but remained totally theoretical. Many scientists in the decades that followed Einstein, including Stephen Hawking at times, argued the possibility that they weren't even real. We're going to dive into some of the latest discoveries surrounding black holes in this multi-part series. But first, be sure to like, comment your favorite thing about black holes, smash that subscribe button, and ring that bell to never miss a video. I'm Eric Malachite, and this is Science Get. A black hole is an object in space exhibiting a gravitational pull so strong that even light can't escape it. As far as we know, the cause for this is because matter in black holes is so densely packed into a small space. Black holes that are about the size of our sun are thought to be only 6 kilometers in diameter. They're formed when stars much larger than our own go supernova, leaving behind a super dense core of material that can collapse in on itself if massive enough. Most stars that are 5 to 7 masses greater than our own will turn into neutron stars when they eventually go supernova, a subject we've talked a lot about on this channel.
We love neutron stars and magnetars.
Although black holes are seen as some of the most terrifying objects in the universe, they're a lot less dangerous to us than many people think. Sure, some supermassive black holes generate effects that can rip their galaxies apart. But there are a surprising number of benefits to life around a black hole. For one, there's one at the center of our very own galaxy. And we're okay, aren't we? Well, marginally. 2020 did a number on us. But just because our experience with Sagittarius A, our supermassive black hole, has been relatively calm in recent galactic memory, it wasn't always so. The Fermi bubbles appear in artistic renderings of our galaxy as two bright pink bubbles stretching far above and far below our galaxy. In reality, they're composed of faint irradiated gases and encompass an area of 25,000 light years in both directions. They're also extremely faint in our normal visual spectrum. Up until last year, it was thought to be impossible to image them directly without using a gamma ray telescope like the Wisconsin H-alpha mapper. However, the data coming in about the Fermi bubbles is painting a much more violent picture of our galaxy's past. Based on new data, scientists believe that Sagittarius A erupted some 3.5 million years ago, lighting up the prehistoric Earth's night skies. This explosion would have stretched even further than the Fermi bubbles do, reaching an estimated 100,000 light years both above and below the galaxy. It would also have been visible to early evolving humans on the planet. Considering that the last major extinction event was 65 million years ago, it's safe to say that this explosion likely did no harm to the Earth, at least not that we know of. Sagittarius A, however, could erupt again in the future, though it's probably safe to say that the Earth will be okay. It would still be one hell of a light show though. But the relativistic jets of other galaxies put our Sagittarius A to complete, absolute shame.
Shame.
No, that's probably a good thing for us. Relativistic jets are intense and powerful explosions of gas and super-energized particles, moving at or near the speed of light. While the mechanics are not greatly understood of how such powerful blasts of energy are capable of defying the gravity well of a supermassive black hole, it's thought that these particles break free when the black hole feeds on material.
Feeds.
When a star gets close to a black hole, it gets torn apart at the seams, stretching it around its equator. This is called an accretion disk. This feeding causes materials in the accretion disk that aren't actively falling into the black hole to be shot out of orbit around the black hole at relativistic speeds, hence its name and all. These jets are extremely bright and can travel for tens of thousands, if not millions of light years. The Centaurus A radio galaxy is one of the closest galaxies to Earth, and it just so happens to be one of the best examples of relativistic jets in action. Its jets are so powerful that the gases and particles that make them up are traveling at 50% the speed of light, and cover a distance of 10 to 16 million light years. I mean, just look at them. They dwarf the whole galaxy. These jets also emit powerful X-rays and radio waves, which scientists have been analyzing since its discovery by Scottish astronomer James Dunlop in 1826. What's terrifying though is that the relativistic jets coming from supermassive black holes can generate enough power to consume an entire galaxy. But black holes aren't just bringers of death and wibbly-wobbly, timey-wimey dilation effects, but theoretically, they could also host habitable exoplanets. Crap. I triggered the alarm again. Okay, so this isn't our speculation. It comes from a new research paper by Dr. Jeremy Schnittman of NASA and a column written by Sean Raymond, astrophysicist at the Observatory of Bordeaux in France, called Building the Ultimate Solar System. We humans are more than a little biased when it comes to the search for extraterrestrial life, or habitable worlds, which is understandable because from our perspective at least, the Earth appears to be fairly unique. But just because life formed on our world in our specific circumstances doesn't mean it can't also show up on other worlds in much more extreme environments. Schnittman's paper speculates, using some handy equations to back up his words, that exoplanets orbiting around black holes would experience enough tidal heating to allow for liquid water to exist on the surface. Life as we know it, however, needs more than just heat. It needs light. So how would an exoplanet around a black hole experience light when we know black holes are invisible? Luckily, the matter around black holes can create the light our exoplanets need for life to thrive. And the answer lies in cosmic microwave background radiation. Now, the CMB is cold, about 3 degrees above absolute zero. But when it gets sucked into a black hole, it heats up faster than Eric makes carne asada fries disappear. Hey, who wrote that? And if the black hole is spinning, it can create a light show around it that is as bright as our sun. You've all heard of habitable zones, I hope. And Sean Raymond, the astrophysicist we mentioned earlier, thinks that as many as 1 million Earth-like worlds could orbit a black hole of the right size. I guess size does matter. And the amazing thing about what he's suggesting is that all of those worlds could also host life, because all of them would be within the black hole's habitable zone. Yeah, think about that. Black holes could have habitable zones. Scientists understand 2 types of black holes better than any other: stellar mass black holes and supermassive black holes. Stellar mass black holes are equal in mass to our sun, or many suns, and form when they go supernova. But you know that. Supermassive black holes are millions of times bigger than our sun, and they're thought to be the driving force behind most, if not all, galaxies. There is a third class of black hole, but it's poorly understood at the moment, so we're not going to talk about it. We know that black holes are extremely dense, and a common question Raymond gets in the physics classes he teaches is, what would happen if a black hole with the same mass of our star replaced the sun? Well, the answer is nothing. Nothing in terms of the orbits of the planets, at least. It would obviously get pretty freaking cold here on Earth without the sun's light and warmth. That goes without saying. But if the sun had a black hole companion of equal mass, things would get a bit more interesting. The orbits of the solar system would still not change all that much, though Earth's year would be shortened to about 258 days. About 6 planets can fit snugly within our sun's habitable zone. But a supermassive black hole with a mass equal to 1 million suns would have a habitable zone that could theoretically fit 550 Earth mass planets in stable concentric orbits, as long as you put 9 suns, yes, suns as in plural, in orbit around it. And that's not all. If we put even more suns around this black hole, we can increase the number of habitable worlds that can orbit around it greatly. One might even say exponentially. But we'll have to talk about how this is possible in part 2, which will be out in just a couple days. Lucky you. If you enjoyed this video, be sure to drop me a like and tell me what you think it would be like to live on an exoplanet orbiting a black hole. This is a question we'll be answering next week, so let's see how many of you get it right, or as close to right as speculation can get. But yeah, and be sure to smash that subscribe button and ring that bell to never miss an episode of Science Get. I'm Eric Malachite, and I'll see you next time.